Hello everyone, welcome back to Math with Amala. Let's move to grade 9, chapter 1, part 6, which contains the exercise 1.2. First question is to state true or false. Every irrational number is a real number. Let's take P by Q. Any number which is of not the form P by Q is irrational, but in real number we are having rationals also. Irrational plus rational is real number set. Let's take the irrational numbers root 2, root 3, root 5, pi, etc. Actually, these are real numbers. We have to prove irrational numbers are real numbers. So, actually, this is a true statement. Real numbers consist both irrational and rational numbers. Every point on the number line is of the form root m, where m is a natural number. Let's take the number line. Let us take 3. Root m is equal to 3. Root 9 is actually 3, where 9 is a natural number. If root m is equal to 2, root 4 is 2. 4 is a natural number. Let's take the fraction 1 by 2 from the number line. But we know that it cannot be represented like any of the roots, where root m is equal to 1 by 2, where m is a natural number. This is not possible, hence this is a false statement. Every point on the number line is of the form root m, where m is a natural number, is a false statement. And we can give one more example with the negative numbers, because no negative numbers can be the square root of any natural number. Now let us move to the next one, the third statement. Every real number is an irrational number. Actually, this is false, because every real number, let's take some real numbers like 2, 3, 4, 5, 6. They are all real numbers, but actually they are not irrational numbers. Irrational numbers. So this is a false statement. Irrational numbers are only root 2, root 3, root 5, root 6, like that it goes. The second question is, are the square roots of all positive integers irrational? If not, give an example of the square root of a number that is a rational number. So let's take some positive integers and their square root. They are not actually irrationals, because let's take an example of root 9, which is equal to 3. 3 is a rational number. And also root of 16, which is equal to 4. This is also a rational number. So you can take these examples in order to prove the rationality. Next one, the third question. Show how root 5 can be represented on the number line. Here we can use the same method that we have used for the representation of root 2 and root 3 on the number line. So I will explain this in detail, including the root 2 and root 3 explanations. So here we have a square with 1 unit measures, and we have done the root 2 and also root 3 also represented there, and we have to represent this root 3 on the number line on the x-axis or on the baseline. So you can see here how I have completed the figure by continuously extending the unit 1 measures from B, C, D to meet at EO and to get the root 5. Okay, here OB is equal to root 2, which is equal to root of 1 square plus 1 square. OD is equal to root of root 2 the whole square plus 1 square, which is equal to root of 2 plus 1, that is root 3. And OC is equal to root of root 3 the whole square plus 1 square, that is root 3 plus 1, that is root 4. Now OE is equal to root of 4 the whole square plus 1 square, that is root of 4 plus 1, root 5. This is the line that we need as OE, whose measure is root 5. Now let's see how we can represent this on the number line with the arc method. By using the compass and all, we can make one more representation on the number line. Now we have just represented it in the figure by extending 1 unit in the right angle ways. Okay, let's draw a number line which contains 0 and 1. And with 1 unit distance I have drawn a square, 1 unit measure I have drawn a square. Now that's diagonal represents root 2. Now the red line is of 1 unit, and that red line that bigger red line is of root 3 measures. Then a bigger green line is of root 4 measures. Bigger yellow line is of root 5 measures. You know that all the smaller colored lines are of unit 1 length, and they are in perpendicular with the previous rational numbers. So we have drawn here root 2, root 3, root 4 and root 5. Let's take this distance from 0 to E, that is root 5 in our compass. Next step is to mark the root 5 distance in our compass on the number line, which will be representing the value of root 5 on the number line. Okay, so I have marked here with some measures. You can accurately do with your compass. Representation of root 5 is marked here at that point, root 5. Okay, let's move to the next video in the next part. Please be stay tuned till then.